I'm here to present to you about immersive AR and VR experiences using React Native. The key term here are AR and VR and immersive experience. So just before moving forward, I'm Pulkit, flying here from India, and I'm an independent developer and organizing team member of Facebook Developer Circle Delhi. I've been into web development ever since I was age of 14. I've seen the web changing from basic HTML, CSS, to jQuery, to modern frameworks like Ionic Framework, Angular, and finally we are here at React. So just my Twitter handle, you can go there, click my photo, and put it up there. So the agenda for today will be, we'll be talking about XR. Sounds weird, because many of you must be hearing about AR, VR, MR. There are people talking BR. So there are many terms. So Mozilla just came up with a short form called XR, where X may belongs to A, V, or M. So we'll be covering up what is XR, why you need to know about XR, how it's done using React Native, and finally, when you should be caring about it and when not. A really great person once questioned, reality is merely an illusion, albeit a very persistent one. So I'm not sure if it's for real I'm standing here or not. So when I was a child, and during Halloween, my mom and dad used to say me, ghosts are just an illusion. And when I just saw the last slide by Albert Einstein, are ghosts real? So remember on the very first slide when I said immersive experience is an important key term here. Why? Whatever you see right now, or whatever you experience, is something which is outcome of your past experiences and the current situation. How you are molded up in past shapes up your future and makes you experience things. So same with the VR and AR stuff. Whatever you'll see totally depends how you senses the reality around you. So let's play with our mind a bit. I'll play a sound, just hear it up. It's supposed to stop here. OK, so how many of you just heard it ascending tone? Probably all. It's just a single monotone which is repeating here. But since I'm showing you a ladder, you are visually being illusionized to see this as an ascending tone. And this is called Shepherd tone illusion. Another one. What's the guy saying? Is it right? Sure. You heard far, far, far. But believe me, it was the same sound playing in the background. That's again a monotone illusion. So the conclusion of this thing is, the thing which we trust the most can be tricked pretty easily. Never trust your brain, huh? So what are the tools to trick our really amazing mind? We have got 5 sensory organs: your sense to touch, your ear, the smell, your sense to taste, and how you see things. We can use them to trick your mind and make you believe you're at a totally different place. And this led to the inception of a term called virtual reality, where we actually trick up your mind using multiple sensory illusion and make you believe you are at some other place. Most of us believe VR is a term which is being introduced to us like really recently. But the reality is it dates really back. 1740s, when the painters started painting panoramic images, they actually grab whole field of view, and you end up having an illusion that you're actually in the image itself. So that was the one thing which actually led to the inception of term not augmented, but artificial reality back then. Then in 1838, we got introduced to stereoscopic images. We got introduced that our left eye and right eye see different images, and if we put them really close to our eye, we might believe we are at some other place. So it was back in 1838 by Charles Wheatstone, which actually laid the foundation of cardboard VR. Next, we have a cave system designed in 1929. What is a cave system? Nowadays, you are really accustomed to those big head-mounted display put up on your eyes. But back then, there was a big room in which all 6 walls were made of displays, where you can sit inside and believe you are in a virtual reality environment because everything around you is being overlaid by the displays. Following that, back in 1934, we had a movie which actually predicted VR. And finally, in 1950s, Mr. Morton Helix introduced to Sensorama. It was a machine, or rather I'll say a full-fledged VR machine, which not only tricked your visuals, but also with your binaural sounds. They had smells coming up so that if there is a scene in which you are in a garden, there is a flowery smell over there. So basically, it was the really initial stage of 4DX. And finally, in 1965, Mr. Ivan Sutherland introduced to us the HMD, head-mounted display. It was so big machine that it used a crane to mount on your screen. And if you just travel up night, it will just fall on you and you might die. So back till then, the original term which was used to refer to virtual reality was artificial reality. And in 1987, the whole new field was made called virtual reality. And scientific research started on it. In 1993, Sega announced their VR headsets. And really soon, Nintendo also launched their VR headset. Coming far to 21st century, Google launched their Google Glass, and it was the future of VR. So what's the end objective from all this whole research? Immersion. Immersion is the key which make you feel you are in a different world. And the only target as a VR developer you are being provided with is to make an immersive experience. So there are 3 principles which governs how much immersion is there in the headsets. So think of you getting into a bar, and when you get in, you'll see a really nice lighting environment, a really sweet bartender over there. So you start feeling you are in that particular world. That's the place illusion. If I start showing you those screens in that virtual headset, you'll feel you are in a place. Second thing is plausibility illusion. What it means, if I'm just moving around and I touch someone and he won't respond to me, I'll end up feeling that it's just a virtual environment and I'm not into it. So plausibility illusion is all about if I poke someone in the environment using my controllers, they respond back to me. That's the plausibility illusion. And finally, the embodiment illusion. Usually the VR machines or VR headsets make you have a digital avatar. What happens is when you move your hand, you'll see a digital hand moving on your screen. If you walk forward and see down, you'll be able to see your virtual feet. So that makes you illusion you are in a different body. And that's something in our LGBT community I've been using. Just if a girl wants to experience how being men feels, they can come over and wear a headset and they'll have a male body. Now the question is, what about the real reality when you're wearing those headsets? Because it's just taking away your field of view and you're not aware what's happening around you. And this led to the term AR, or the augmented reality. Augmenting some information over your screen is all about augmented reality. So AR also dates back really long when you started doodling over your images. If I'll just write, I'm here at this particular location on my image, that's also AR, because you're augmenting additional information on the picture itself. So after the doodles, we had a 2D filters, which make you put on temperatures, location, everything you use on your Snapchat or Instagram stories. Then Snapchat came up, really new features like putting up the digital objects on your real world. That was another major leap in augmented reality. Then the very own Google Glass, which might ended up being a failure, but again, it was something which made us realize the future of AR, or mixed reality. And finally, as our last speaker, Ned, talked about Pokemon Go, Pokemon Go was one of the major leap toward the augmented reality. You might have seen people moving around on the road just to catch a Pokemon. So, before continuing about why you need to know, we need to understand history of UI and UX. Before reaching to this point, earlier, the developer used to interact with machine using punch cards. Later, we got introduced to the keyboard. Then we got introduced to the mouse. Presently, we have touch-based user interfaces. We have Alexas coming up, voice-controlled UIs. But what's the problem with it? We all are 3D beings, but we are interacting using 2 dimensions. So it's lacking immersion. And the future of UI and UX is all about virtual reality and augmented reality, making you interact in a 3 dimension. So we have 2 kinds of AR systems available. The first one is marker-based system, where you just put up some marker on your like a stable surface and point your phone to it, and you get overlays on it. And another one is marker-free augmented reality. You can work on both of them. Now, a really big misconception today in the world is it all about entertainment field? No. We have virtual reality being used in the field of medical, where in medical colleges, students are being taught to work on surgeries using virtual reality headsets and virtual reality controllers. The British Army is using VR technology to train their soldiers and even help them out to come out the post-traumatic disorder they have after experiencing the war. So that's something they are using. And similarly with AR and its application. This is Microsoft HoloLens. You can do these all things. You can work together. You can work on 3D object or 3D designs. You can put up overlays of screen displays on your home or everywhere. This is location-based augmented reality, where you can point out to something and get to know which place is it. So, how we as React developer can start entering into this UI and UX field, since React mentioned its future of building user interfaces, and it must be helping us to make AR and VR things. So we have a wrapper for ARKit and ARCore. ARKit and ARCore are the native modules launched by Google and Apple to interact with low-level APIs available to us for augmented reality. So we have a wrapper called React Native ARKit and React Native ARCore, but it's still experimental stage, and it works around the native code. You can try it out. If you're a really hardcore designer, anyone here who have worked with 3D modeling? So you must be aware of Unreal engines and Unity 3D. So they are really powerful one, but the thing is you need to learn C# scripting for that. They're really powerful. But they have a problem. If you are doing some UI-intensive task, you cannot rely on that. Then we had React 360 launched to us, but it was only for VR and not for augmented reality, and have very limited support for 3D models. So we'll be using a really new library called ViroReact, which was launched, I guess, somewhere around 6 to 7 months back, have a really great documentation, allow you to write a code once for iOS and Android and is cross-platform. Based on React Native framework, have a native thread and a really powerful renderer for rendering all your 3D objects. Yeah, it has lighting, physics, particles, HDR support, and a lot of things. So how you get started with Viro? I'll prefer the second one. Just do a global install of React Viro CLI, and I need your project with that. So not delaying, I'll just show you a demo what you can do with Viro. OK. So we have Halloween coming up. Let's bring some little person here. You can see around. How about putting a snowfall here? Say hello. So how about going to some other dimension? I'll just run through it. So you're at a totally different place. Let's come back to React Conf. We are here. This deserves some fireworks. How about this? No fireworks? I'm sorry, guys. So yeah, that's all. Even more than that, you can do with Viro. We'll continue how we can code those things. So for me, using ViroReact, we have component which can be used both for VR and AR, and few AR-specific and VR-specific component. The nomenclature is this way. If any component is cross-reality, you can directly use it as Viro Sound, Viro Display, Viro Scene. That's the XR. If any component is VR-specific, it will be like Viro VR Screen Navigator. If any component is AR-specific, it will be Viro AR Router. So the terminology goes like this. Cross-reality component do not specify anything in between. The one which are specific to particular reality, they are named in this fashion. Oh, sorry. So the basic componential layout works this way. Just like in your React Native, you wrap everything around a view component. To show anything in ViroReact, you create a Viro Scene component. It's analogical to view in React Native. Just like any H1 or H2, or in React Native, just like text, we use Viro text component. The Viro text component allows you to put any text in your augmented or virtual environment. So before continuing, we need to understand how positioning works in virtual reality or augmented reality system. There are two kinds of rules. Probably all physics students must be knowing about it: left-hand rules and right-hand rule. So we use right-hand rule while positioning thing using ViroReact. How we can do that? Just put your middle finger pointing yourself. Pun intended. Your index finger up and your thumb toward right. This shows the positive z-axis is toward yourself, the y-axis is upward, and the x-axis is toward your right, towards your thumb. Now, what it result is you are facing towards the negative z-axis. So if you want to place anything, any object further from you, you place it in negative z-axis. And think it like you're standing in between a sphere. And you can position anything. You're in the center of sphere. The center is called 0, 0. And everything around the depth goes with minus z-axis and positive z-axis. If you want to go up, it's positive y-axis. Go down, negative y-axis. And similar way with the x-axis. So we just saw a portal where I just entered into a beach environment. So we can have multiple backgrounds in our environment. So we have two ways possible. One is just putting up a 360-degree image. That's done using Viro scene, and just put a Viro scene, and inside that put a Viro 360 image and mention the source of your 360-degree image. Similarly, you can use Viro skyboxes. Skyboxes are just, so think it like you're standing in the middle of a cube. And cube have 6 sides. One is in negative x-axis, positive x-axis, negative y, positive y, negative z, and positive z. So what you do is you specify every image which you want to put up on those faces of cube. So the second screen you can see is how to put up the skyboxes. Lighting in virtual environment. We have 4 kinds of lightnings available. I'll come to this slide later. I'll show it from this one. Any point light source is the one which starts at particular point and illuminate in all direction, as you can see here. Spotlight is something which starts with one place and projects a conical illumination, which has an internal angle and outer angle. Next, we have a directional light. Directional light is something which projects in only one direction. And the last one we have is the ambient light. The ambient light is something due to which you can see anything. It's not coming from one direction. It's like general illumination of any object. So for ambient light, you can use Viro ambient light component. For spotlight, you can use Viro spotlight component. For directional light, you can use Viro directional light component. And finally, for the point light, you can use Viro omni light component. That's a general code of putting up things on your screen with a 3D object, which is being illuminated by a spotlight. You can see we are positioning it at minus 0.25. That means it's sitting right in front of me. Then we have a color. It's #77. I don't know which color is it. So the direction of light is represented by a vector. It shows it's in minus z-axis. So it's pointing toward the way I'm looking at. We have an inner angle and outer angle. It means it's a spotlight or a conical light. And finally, we have an ambient light. It's a general illumination. And we have a 3D object here, which is being illuminated by all these things. Moving forward, we just saw a Halloween creature over here. Those all are 3D objects. So ViroReact supports a lot of 3D objects and a lot of formats for that. But since we are using it on mobile devices, we need to make sure they are low polygon files. Because the higher the polygon, it will be difficult to render and leads to laggy experience. And if it's laggy, there's not much of immersion in it. So, supported format for 3D files in ViroReact. You can clap for me too. .obj file. The .obj file do not support any animations. You don't need any conversion script to put those OBJ files in your Viro environment. .fbx file supports animation, but in order to show that, you need to convert those fbx file to vrx file using a script available as in ViroReact. And finally, we have a really new file format called gltf. It's just a JSON structuring which contains all information about your 3D object, a bin file which contains the binary data of your polygon meshes, and finally a PNG file which governs the colors and texture of your images. Moving forward, from where can you get these 3D files? You can use Unity Asset Store, you can use Maximo, you can use Sketchfab, Google Low Poly. You can model it yourself using Microsoft Paint or Blender, or if you're really advanced, you can use Maya 3D. And that's how you can put any 3D object. Just mention the source, write the position. If you want to put any transformation to it, you can scale it up or rotate or anything. And you can also add animation. Since you are seeing we are using .vrx file, we have mentioned the animation here. Next, we have particle effects. I just presented this place. I got snowfall here. So Viro particle system is used to showcase those particle effects. Those all particles, anything which you want to be repeated in thousands or hundreds of thousands of number in a looped manner, you use particle effect. How you put it up? Simply choose the image source, enter the rate at which you want to show those particles, and start the emitter. That's the general code for that. Simply write the Viro scene. Inside the Viro scene node, you can put the particle emitter, put the position, duration for which you want to show that, and write the emission rate. Finally, moving to the end, when to use ViroReact and when not to. If you're making something really graphic intensive, let's say you're making a future Pokemon Go or any new game, you should not use ViroReact because it's for making user interfaces and not for the games. If you are not building anything for high-end headsets like Oculus or, let's say, HTC Vive, you should avoid using it. If you're targeting Google Cardboard headset, go for it. Finally, if you're targeting both AR and VR, go ahead. This is the best option you have using React Native right now. Thank you, and let's build the future of UI and UX together.